Hello everyone, this is the third part of Encoder, and in this video we are going to learn how these priority encoders can be designed. Priority encoder, this is the another type of a encoder. So what is priority encoder? So this is the special type of encoder with priorities assigned to all its input lines. If two or more input lines are run at the same time, then the input line with the highest priority will be considered. If we take the example of a keyboard, or it may be the keyboard of a laptop or a computer or a mobile or a calculator. So in the keyboard, if we type or if you press the two keys at the same time, then the key will which have highest priority that will be appeared on the screen. If you type if you press the keys with numbers 0 and 1 at the same time, then 1 will be displayed on the screen because the key with a number 1 has the highest priority. If you press the keys with a numbers 2 and 5 at the same time, then the number 5 will be displayed on the screen because the key with a number 5 has the highest priority. So this is the priority encoder where the priorities are assigned to all its input lines. If two or more input lines are run at the same time, then the input line with highest priority will be considered. So here we are taking the example of a 4 to 2 priority encoder. So here is the block diagram for this priority encoder. We have 4 input lines, that is D0, D1, D2 and D3, and we have 2 output lines, that is Y0 and Y1. So it is Y0 and Y1. So this is a priority encoder circuit, combinational circuit. So here, if we select the line D0, if we select the line D0, then at the output or the output, two outputs Y1 and Y0, they will be the outputs Y1 and Y0, they will be equal to 0, 0. If you select the input line D1, then outputs Y1 and Y0, they will be 0, 1 or 0, 1 will be displayed on this outputs. If you select the input D2, then the output Y0 and Y1 will be 1, 0, and if you select the output input D3, then outputs Y1 and Y0 equal to 1, 1. So here are the inputs, they have assigned the priorities. So D0 has the lowest priority, then D1 has the highest priority than this D0 input, but has the lowest priority than this D2 and D3. Again, D2 have the highest priority than D0 and D1, but has the lowest priority than D3. But the input D3 has the highest priority. Okay, and if we can select the any input line from this 4 input lines, then these are the outputs which will be displayed on this output Y0 and Y1. So here is the truth table. So this will display or describes the operation of this priority encoder. So we have inputs, that is D3, D2 and D1. So it is D3, D2, D1 and D0. So these are the inputs. It has the highest priority. D3 has the highest priority, and these are the input. Okay, these are the inputs, and we have a priorities or the outputs, that is Y1 and Y0. So these are the outputs, and this has the lowest priority. This D0 has the lowest priority. Now here, if we doesn't select any input, that means this D3, D2, D1 and D0, they are 0, 0. We doesn't selected any input. So the output, it will be don't care. Okay. If it doesn't select any input, then output will be don't care, or it may be a previous state. Now if you select the input D0, then the output will be 0, 0. Okay, if we select the input D0, then output will be 0, 0. Now if we select the input D1, now here D0 is don't care. Whatever is the status of D0, it may be 0 or a 1. It will not be displayed on the output, only D1 is considered and the output will show 0, 1. Now if we select the input D2, now this D1 and D0, they whatever they have the status, but the only D2 will be displayed on the output, and that is 1, 0. And if we select D3, then all the three inputs, that is D2, D1 and D0, they are don't care. Whatever status they have, only 1, 1 will be displayed at the output. So this is the truth table which describes the operation of this priority encoder. Now we have to plot the K-maps to find the equation to draw the logical diagram for this priority encoder. So we have to plot the K-maps for outputs Y0 and Y1. So here we have a 4 inputs. So we required 4 variable K-map. So for Y0, plot the K-map. So here we have a inputs D3, D2, D3 bar, D2, D3, D2 and D3, D2 bar. And here we get D1, D0 bar, D1 bar D0, D1, D0 and D1, D0. Now we have to plot the output Y0 on this K-map. So we have to check for which input combination output Y0 is 1. So here it is Y0 is 1 for this. Here D3 is 0, D2 is 0. D1 must be 1 and D0 maybe it is don't care, that means D0 may be 0 or may be 1. So here D3, D2 is 0, 0, that means D3 bar, D2 bar. So this is the row and D1 must be 1. So here D1 is 1 and D0 is don't care. So D0 may be 1 or D0 may be 0. So this is the line where we have to plot this 1. So here we have to plot the 1. Next is here for the input combination, that is D3 must be 1 and D2, D1, D0, they may be 0 or 1, but D3 must be 1. So here these are the two rows where D3 is 1 and here D2 is 0 and D2 is 1 over here. So we don't consider this status of this D2, we have to just check D3 is 1. So here for these two rows D3 is uncomplemented, that means D3 is 1. And here D1 and D0, they must be don't care. So D1 and D0, whatever status of this D1 and D0, if they are 0, 0, 0, 1, 1, 0, 1, 0, so no issue. We have to just check D3 must be 1. So here we can plot the 1s and put 0 in the rest of the cells. So here find the highest group, that is octet, and here is the quad. So we get two groups, one octet and one quad. Here one octet and one quad. Oh sorry, this must be here. D3 and D0, they are 0, 0. So here we get the quad. This is the quad. So for this octet, only D3 is constant and all the three variables D2, D1 and D0, they have changed. So for this octet we get the variable D3 only, and for the quad we get the variable. So we have to check these two rows, D3 bar, D2 bar and D3 D2 bar, and these two columns D1 D0 D1 D0 bar. So here D2 bar is constant, D3 is eliminated, and here D1 is constant and D0 is eliminated. So we get the equation D2 bar D1. D2 bar D1. So this is the equation for Y0, that is D3 plus D2 bar D1. So here we get Y0 equal to D3 plus D2 bar D1. Now what? We have to plot the K map for the output Y1. For Y1. So here we get D3 D2 bar, D3 D2, and here D3 D2 bar. Here we get D1 D0 bar, D1 bar D0, D1 D0 and D1 D0 bar. So we have to plot the output Y1. So here Y1 is 1 for these two input combination, where first is D3 is 0 and D2 must be 1. So D3 is 0 here and D2 must be 1. So here D3 is 0 and D2 is 1 for these two combinations. D3 is 0 and D2 is 1. Now D1 and D0 they are don't care. So here we get 1 1 1 1. So D3 must be 0, D2 must be 1, and D1 and D0 are there don't care. That means whatever is the combination of this D1 and D0 don't care. Just plot 1 for this D3 bar D2. Now it is 1 when D3 is 1 and all other inputs they are don't care. So here is D3 is 1 and D2, D1 and D0 they don't care. So here we get the 1s. Put zeros in the rest of the cells. So here we get 2 octet. This is the 1 octet and this is the second octet. So we get the equation Y1 for this first octet. So this is the first octet. So here we get D2 is constant and all their changes, so that is eliminated. So here we get D2, and for this second octet check this. So here only D3 is constant. So we get D2 plus D3. So these are the equations for the output Y0 and Y1. Now we have to plot the diagram. So here we have a 4 inputs, that is D3, D2, D1 and D0. But here we required complement of a D2. So here we have taken the complement of D2 only, and all other variables or inputs they are in the uncomplemented form. So we have taken this as a single line. Now our output Y1 is D2 plus D3. So here D2 plus D3. So our operation is there. So here we get output Y1. For Y0 it is D3 plus D2 bar D1. Here D2 bar D1. So here we get the output Y0. So this is the here is the AND operation between this D2 and D2 bar and D1, and here is the OR operation between these two terms. So here we get the output Y0. So this is the simplified diagram, logical diagram for the priority encoder.